Okay, so to introduce trigonometry, we have to remember what we learned in geometry and Algebra 2, which is sine, cosine, and tangent. For many of us, we remember it by talking about SO, CA, and TOA. That reminds us of the basic ways to set up the fractions, the ratios. Sine is O over H, which is opposite over hypotenuse. Cosine is A over H, so adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. You perhaps remember last year from Algebra 2 that there are really 6 ratios. The reciprocals of sine, cosine, and tangent exist. Sine is the reciprocal of cosecant, and so cosecant is hypotenuse over opposite. Secant is the reciprocal of cosine, so it is hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so it is adjacent over opposite. Okay, so the first skill that we're going to practice is taking a set-up triangle, right triangle, and setting up these 6 ratios for it. Remember, you have to look from the angle that is labeled. They're asking us to look for theta. So we're looking from this angle right here. Remember, hypotenuse is across from the right angle always, so 17 is the hypotenuse. And then opposite and adjacent have to be identified. If you can start at your angle and draw a line, the side you bump into is the opposite, and the side you're next to, you're adjacent to, the side you're touching is the adjacent. So if we're going to do sine of theta, cosine of theta, and tangent of theta, we have to know our ratios. So sine is opposite over hypotenuse, which would be 8 over 17. Cosine would be adjacent over hypotenuse, so 15 over 17. And tangent would be opposite over adjacent, so 8 over 15. Okay? And so then we have to memorize the new names. Sine is the reciprocal of cosecant, so CSC. Cosine is the reciprocal of secant, so SEC. And tangent is a reciprocal of cotangent, which is COT, cot. And now we can just do the easy thing of making the reciprocals. So 17 over 8, 17 over 15, and 15 over 8. Okay? At this point, stop the video and complete problems 1 and 2 on your worksheet. Okay, the next skill for our trigonometry chapters is going to be something called rationalizing the denominator. That means that it's the process of removing a radical, a square root, from the denominator without changing the value of the fraction. So think for a minute, how would you get rid of a square root? Normally we would square to get rid of a square root, right? Well, if we square this fraction, though, we would change its value because we would multiply the top part by 5 and the bottom part by the square root of 11 if we multiplied it by itself. And that's not okay to do. We can't multiply the top and the fraction by 2 different numbers. So we just need to focus on squaring the square root, multiplying the square root by itself. So that's what we do. We multiply the bottom of the fraction by another copy of the square root, which means we have to multiply the top of the fraction by that same exact value. That way we don't change the value of the fraction. So what happens on the bottom is you have a square root of an 11 times itself. So you have a square root of 11 squared, basically. And we know that square root and square cancel each other off, and we would just have an 11. On the top, we have 5 times square root of 11, which doesn't combine and doesn't do anything. So that's just the top. 5 times the square root of 11 divided by 11. That's the whole procedure. So think about what would you have to multiply negative 2 times the square root of 6 by to remove the square root of 6 from the denominator of the fraction? Well, a copy of the square root. So we'd multiply by the square root of 6. Whatever you do to the bottom, you do the same to the top. So on the bottom, we would have the square root of 6 getting squared because we're multiplying it by itself, which cancels off the square root, and we would just have plain 6. On the top, we have negative 2 times the square root of 6 because there's nothing to do with that. Now this one has one additional step because the fraction that we have left, 2/6, can actually simplify. If we simplify 2/6, then we could divide by 2 and get a 1 and a 3. So this would actually be negative 1 square root of 6 over 3. All right, one more time for good measure. What would you multiply the last fraction by? A copy of the square root, so square root of 18, bottom and top. So on the bottom, square root squared equals 18. On the top, 3 square roots of 18. And then you ask yourself if anything in your fraction can simplify. 3/18. Sure, 3/18 can divide by 3. So that would leave us with a 1 and a 6. So square root of 18 over 6 is our rationalized answers. Okay, at this point, turn off your video and do problems number 3, 4, and 5 to try this out. And then put it together. Combine our 6 ratios with rationalizing the denominators for any answers that end up with the square roots in 6 and 7. Okay, our final skill is involving graphing points and drawing angles and identifying quadrants. So first, when you draw a graph in the coordinate plane, it breaks up the plane into 4 corners, known as quadrants. Starting here, where everything is positive, this is known as quadrant 1, and then rotating counterclockwise. So this is quadrant 2, quadrant 3, and quadrant 4. We need to get familiar with that vocabulary so that we can all talk about the same locations. All right, so if we were to graph a point, let's make up a point. What if we had -7, 5? Okay, so we'll draw a graph. These are going to be sketches. We're going to say -7. Let's see, that would be 7 left. +5, it would be 5 up. So let's put it about right here. Doesn't need to be precise. We're going to draw an angle in standard position. From Algebra 2, hopefully you remember standard position starts at 0, 0, and along the positive side of the x-axis. And so if this point is on the ending side, then we would connect it right there. So that's our angle. And then we want to name the quadrant in which this angle ends. So over here, this point is located in this place here, which is quadrant 2. So our final part of our answer would be to label this as quadrant 2. Problem done. Okay, what if we had one more example here? Let me slide this up a little bit. Let's make up a second point. What if we had 10, -4? Okay, so we make a very rough sketch. We know that 10 is positive, so it would go to the right, and 4 is negative, so that would go down. Let's say it's here. We want to make the angle in standard position, so we start at 0, 0, and on the positive side of the x-axis. And our point needs to be on the end side. So there it is. And then our last part is to identify what quadrant we just ended up in. Well, that is the final quadrant. That is quadrant 4. So we label that quadrant 4, and that problem is also done. Okay, so flip your worksheet over to the back and do this work for problems 8 through 13, and you're done. Prepare to turn it in the first day of class next trimester.